Welcome back to Arxflix. Today, we're delving into an innovative research paper titled A Text-Guided Protein Design Framework. This pioneering work explores how textual descriptions can be leveraged for designing proteins, addressing a gap in current AI-assisted protein design methodologies. Traditionally, protein design has relied heavily on sequential and structural data. However, there's a wealth of domain-specific knowledge locked in textual descriptions that hasn't been integrated into these models. This research aims to bridge that gap. Here's a snapshot of the protein model pipeline. It shows how textual and protein sequence data are integrated to create more functional and versatile protein designs. Protein, short for Protein Design with Text, is a multimodal framework. It operates in 3 steps: protein clap for aligning text and protein sequences, a protein facilitator for generating protein representations from text, and a decoder to synthesize protein sequences. This approach is driven by a dataset called SwissBrotClap, comprising 441,000 text protein pairs. Let's break it down. First, Protein Clap uses contrastive learning to align text and protein sequence representations. Leveraging the SwissBrotClap dataset, this step creates a unified representation space. Second, the protein facilitator generates the protein sequence representation from the text. This step essentially translates complex textual descriptions into meaningful protein sequences. Lastly, the decoder uses this representation to generate the final protein sequence. The decoder can be either an autoregressive model or a diffusion model, adapting powerful generative algorithms for sequence data. Protein is validated on 3 complex tasks: text-to-protein generation, achieving over 90% accuracy; zero-shot text-guided to protein editing, boasting the highest hit ratio on 10 tasks; and protein property prediction, outperforming other state-of-the-art protein representation methods on 4 out of 6 benchmarks. In text-to-protein generation, natural language guides the creation of protein sequences. When using a transformer-based Arkansas decoder, the retrieval accuracy can exceed 90%. This demonstrates the efficacy of integrating textual data for highly accurate protein design. For zero-shot text-guided protein editing, 2 methods are introduced: latent interpolation and latent optimization. These methods adapt proteins based on textual prompts, achieving the best hit ratio across varied tasks, including stability and structure modifications. Here's a visualization of the text-guided protein generation and editing process. It shows how text prompts are used to generate and edit protein sequences with specific attributes. Lastly, protein is evaluated on 6 protein property prediction tasks. The model consistently outperforms other methods in predicting secondary structures and contacts. This highlights the robustness and generalization ability of the learned representations from Protein Clap. Protein showcases a novel method of integrating textual data with protein sequences, pushing the boundaries of what's possible in protein design. This framework not only opens new avenues for research, but also enhances the practical applications of AI in bioengineering, agriculture, and therapeutics. The researchers envision protein enabling zero-shot protein engineering, using rich textual information to design proteins with specific functions without needing extensive experimental data. That's all for today's video. If you found this summary intriguing, make sure to read the full paper for detailed insights. Don't forget to like, subscribe, and hit the bell icon for more updates on cutting-edge research. See you next time on Arxflix. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.